Hello everyone, hope you all are doing well. So today we have moved to topic 18, and from today we are going to start soil science. And today we are going to do topic 18, that is physical properties of soil. Physical properties of soil. In the next lecture we will do chemical, and then we have to do biological. When we look into the syllabus, we will have we have got soil, physical, chemical and biological properties. So in subsequent lectures we will discuss all the three properties. So moving on, what is soil? How will you define soil? It is a mixture of organic matter. Soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. So we can see it is a mixture of organic matter, mineral, gases, liquids, organism that together support life. So this is how you can define soil. So we will move into physical properties of soil. Physical properties of soil. So first important property is soil separates and texture. Soil separates, separates, and soil texture. So it is divided in different class as per the size. So first class is coarse particle or gravels. Coarse particle of gravels. Coarse particles of gravels. Its size is more than 2 mm. Then we have got coarse sands, that also coarse gravels, then coarse sands, that is 0.2 to 2 mm. Then fine sands, that is 0.2 to 0.02 mm. Then we have got silts, that is 0.02 to 0.002 mm. Then at the end we have got clay, that is below 0.002 mm, smaller than this. So this is the class of soil separates and soil textures, that is sand, silt and clay are most important, but you should also know of gravel. Moving on to the next property, the second property, that is structure of soil. We have got different soil structures, and soil structure is influenced by, these are influenced by air, moisture, organic matter, microorganisms, root growth, etc. These all things, air, moisture, organic matter, microorganism, root growth, etc. all influence the structure of soil. So first of all, moving on to the types, we have got crumb. In crumb you will see irregular shape, a small irregular shape. We have got granular, these are smaller than crumb. Granules, granular. We have got subangular, this shape. This is subangular. We have got angular. In some angle, suppose this is the shape of soil, it will be in some angle. This is angular blocks. We have got prismatic. So in this type of shape, in a shape of prism. So this is prismatic. We have columnar like this. This is columnar shape. We've got platey shape like this in plates. This is divided into plates. So this is platey. So these are some common structure, types of common structure, and now moving on to size class. This was B, types of soil structure. Now to class of soil structure, that is B, class. In class we have very fine. Then we've got some number, second is fine, third is medium, fourth is coarse, and fifth is very coarse. As per size, the very fine is will be the smallest size, and coarse will be have the highest size. Then it is also divided in grade, the structure of soil. Grade, it indicates the degree of distinctness of beds. Indicates degree of distinctness of beds. First of all, we have got structureless. Here beds are not distinct. Example we can see of cement or sand. Now we want to moderate. Here beds are moderately well developed. Fairly durable and distinct, not completely distinct but fairly durable and distinct. After moderate, the third one we have got weak. Beds distinct but rarely durable. Here the beds are distinct but rarely durable. In moderate we will see, you have been seen that each was distinct and durable both. Then we have got a strong, well developed beds, quite durable and distinct. So this was about grade. Now moving on to the density and soil weight. Density and soil weight, that is the third physical character. What is density? You all know mass by volume. So average density of soil is average density of soil is 2.65 gram per cube per centimeter cube. We have got particle density or true density. that is density of solid portion in soil. Particle density is what? Density of solid portion in soil. So the average PD of this particle density of organic soil is 1.2 to 1.7 gram per ml. Of inorganic soil is 2.6 to 2.78 gram per ml. You should remember these facts. This can be asked. These are important facts. What is the specific gravity of soil? It is particle density by density of water. That will let us know the specific gravity of soil. Now moving on to second term after particle density, we have got bulk density or apparent density. Bulk density or apparent density. What is it? It is dry weight of unit volume of soil inclusive of pore spaces. It is dry weight. Dry weight of unit volume of soil inclusive, that is, it also includes pore spaces, inclusive of pore spaces. So average bulk density of soil is 1.5 gram per ml. So this was all about density of soil. Now moving on to porosity of soil. It is the percent of soil volume occupied by pore or interstitial space. That is, you can simply, from porosity you can imagine that is the percentage of soil volume occupied by pore or spaces present in soil. So we have got two types of pore. First of all, we have got micropore, which is non-capillary pore spaces. Non-capillary pore spaces. These have little less water holding, capacity, and they allow free movement of moisture and air. Little water holding capacity and free movement of moisture and air. Then we have got micropore. This is also capillary pore space. The first was non-capillary, second was capillary pore space. So they hold more water than what? But what happens if they hold more water? They restrict the free movement of water and air. Restrict free movement of water and air. So this is what about porosity. I hope you all understand it. Keep making notes, it will help. Now moving on to permeability of soil. This is fifth physical property. Permeability. It is the characteristics of soil that determine movement of water through pore space. What it does? Determines movement of water through pore space. Now moving on to soil color. These are often determined by organic substance. Black or dark grays. The organic substance always have black or dark grays, black color, dark grays, black color. Then iron, the color of iron is brown to red, brown, red, or red is yellow or yellow. We've got silica, lime, and other inorganic substances. Inorganic substances give light white and gray tinge to soil. Light white or gray tinge, light gray tinge. So often the color is influenced by soil temperature, as dark absorbs more heat and often color influences soil temperature, as we all know that dark color absorbs more heat and light color less heat. So you can see in the organic matter the temperature would be more, while as in inorganic matters the soil temperature would be low, as it will absorb low heat. So this is about soil color. Now moving on to soil temperature. It depends on atmospheric temperature and moisture in soil. Depends on atmospheric temperature and in moisture. What moisture will do? It will reduce the temperature, as we all know that water has the ability to reduce the temperature. What soil temperature does? It affects physiochemical and biological properties of processes of soil. Example, soil microorganisms are highly affected by the color. Now we have got the next stage, that is number 8. In number 8 we will discuss soil plasticity, compressibility and erodibility. First we will look into plasticity. What is plasticity? It enables moist soil to change shape. When force is applied. When the force is applied, the moist soil changes shapes. But as the force is removed, they retain their even after removal of force they retain this shape. So what is soil plasticity? In moist soils, they change shape when the force is applied, and when the force is removed they still retain the shape. And now moving on to compressibility. It is the tendency of soil to consolidate or decrease in volume. They compress themselves, so the volume decreases. Then we got erodibility. It refers to the ease with which soil materials can be removed by wind or air. Some soils have high erodibility, they can erode easily. Some soils have low erodibility, they erode in a high speed of winds and water. So what erodibility is? It comes from erosion, soil erosion. It is the ability or therefore ease with which soil can be removed by wind or air. So these were the physical characters of soil. Now one question was asked in previous year. We will discuss it here. Factors affecting soil structure. What are the factors that affect soil structure? And this is important. It was asked a couple of times. Factors affecting soil structure. First of all is climate. Climate highly influence degree of aggregation and structure. Influence degree of aggregation. Aggregates. From aggregates it comes aggregation. Example, in arid region we will show. In arid region there is less aggregation. Number second is organic matter. Organic matter improves soil structure. It improves soil structure. We've been often saying that in sandy and clay soil the organic matter leads to good soil structure. We add organic matter there. We've got tillage. They break large clods into smaller ones. Large clods into smaller ones. Then we've got plant roots and residues. What roots they? They make soil particles to cling together. They make soil particles to cling together. Hold soil particles together. We have got animals. We can give example that we have seen borrowers. Borrowers borrow the soil and make soil particles fine. Moving on to next factors, that is microbes or microorganisms. What microbes do? Example, algae, fungi, bacteria. They keep soil particles together. Algae, fungi, bacteria, etc. Microbes keep soil particles together. What fertilizers? Like sodium nitrate, they destroy granulation by reducing the stability of aggregates. Example, sodium nitrate. They destroy aggregation and reduce stability of aggregates and reduce stability of aggregates. That is why we should prevent applying high amount of fertilizers in soil. Moving to next factor, we have got wetting and drying. Wet and dry. They form cracks, breaks clod. They often say natural tillage, self-tillage mechanism in black soil. What happens due to wetting and drying? They create a crack, and it can see in black soils. We got exchangeable cations. Example, calcium, magnesium. These lead to good structure. Calcium and magnesium. While at nitrogen, it leads to poor structure. So not nitrogen, sodium. Sodium leads to poor structure. We've got inorganic cations. Example, CaCO3. These all affect soil structure. This is number 10. Number 11, clay and water. These also affect soil structure. Water sometimes lead to erosion of soil. So these were some major factors affecting structure of soil. If you discuss these 11 points, I think this will be enough to get good marks with examples. Try to give examples. That's why I am incorporating a habit in you to give examples in every answers, it will enhance your marks. So that is all for today. For any queries, comment, if you like it, press the like button. Do share and subscribe, it will motivate me. That's all for today. Have a nice day. Thank you. In the next lecture we will move into chemical properties of soil. Thank you.